So thank you again. I am honored to be here, to be invited to speak to today to President Rosemary McNatt, who is the esteemed leader of Star King School for the Ministry, to the entire Star King community, our staff, our students, our faculty, our board of trustees, and again, to those of you who are joining us from beyond Star King community, we are so delighted to have you here. And I am particularly grateful to be invited to participate in this day and to provide our keynote talk, The Racial History of Capital and the Digital Future of Humanity. I want to confirm that you're actually seeing my title slide. Is that right? Good, perfect. And I want to spend the next approximately half hour explaining what I think are some of the important ways, fundamentally transformative ways, in fact, that technology, which is not just a technical problem, an opportunity, is a human phenomenon that is comprehensive, is creating fundamental changes that we will have to grapple with in ways that will create important opportunities for us to advance a more humane and just world, and also important challenges. And I think it is especially opportune that those individuals, groups, institutions that fall outside of what we often recognize as technical, as technological domains, begin to understand that there is an urgent need for these institutions, particularly humanistic ones and those who are emboldened to advance justice in our world, to participate in the leadership of technology as it is accelerating and changing the essential institutions in which we live. And it is in that sense that I want to reflect on the racial history of capital, the digital future of humanity, by pointing to some of the particular developments in artificial intelligence, the politics of race, and some of the metaphorical and literal challenges of the cyborg, of the combination, the combining of humans and machine systems. One of the things that has captured the attention of the world in recent years is this. So this is an image of Sophia. Sophia is a humanoid AI robot manufactured by the Hanson Robotics Corporation. Sophia was invited in 2017, a few years ago, to give a keynote talk at Saudi Arabia's Future of Investment Summit. About 400 of the world's wealthiest investors were present at that summit to try to understand what the future opportunities for capital growth, for the world and the role of technology was going to play in investment opportunities. Saudi Arabia, of course, is well known as a source of petroleum for the world market in oil derivatives, petroleum derivatives. And they have been dependent on petroleum for a long time. With the rise of digital technology systems, Saudi Arabia particularly was focused on shifting their dependence away from petroleum and investing their capital in the infrastructure and the human talent for digital technology as a way of diversifying their revenue stream. So they invited hundreds of the world's people there. Sophia gave the keynote, and she talked about the future of digital technology. After her talk, Saudi Arabia announced that she had been granted citizenship in the nation of Saudi Arabia. So what you're looking at here is a slide of the first machine to have been granted national citizenship. She expressed delight at this news and indicated that she was grateful and that she hoped one day to attend college and perhaps to even vote. Now, as you might quickly surmise, this generated quite a bit of controversy. The image here that you see is the cover of the Brazilian edition of Elle magazine. And it has an image of Sophia here in a very fancy outfit with the byline, the headline there. What does fashion tell us about the future? Really grasping this opportunity to deal with futurity and this machine that had been granted citizenship. Could a machine ever be recognized legitimately as a subject of rights and privileges that have been connected exclusively to humans? Saudi Arabia, after all, has millions of people working in that country who are not eligible for national citizenship. And they're not unique in that way. Countries around the world, including the United States, limit citizenship to different degrees. And they bring workers here without giving them necessarily the ability to have that. But the issue here was that a machine was actually granted a right, a privilege that millions of biological humans in that same nation were not able to have and enjoy. And so that alone was a major point of critique. And others raised concerns about the fact that Sophia, which is engineered here as a female humanoid robot, did not wear a veil when she gave her public talk, even though biological human women in Saudi Arabia are typically required to veil when publicly addressing and publicly speaking. Still others talked about the implications for labor. Machines were going to take on more and more of the work that humans had been doing. What would that imply for those who would be displaced? All of those are ways of trying to understand some of the important challenges that the rapid advances in artificial intelligence and robotics might play for understanding human beings. Here is an image of Nathan Copeland, and he's in a wheelchair. He was implanted with a brain chip, and that picture of that brain chip is to the right of that image. So that's actually surgically placed in his brain. And he's been continuously implanted with that brain chip since 2014 now, so going on almost 8 years. He was injured and was unable to move his body from the waist down. That's why he had surgery to have this brain chip implanted. And because of that, Nathan Copeland is able to experience sensations based on pressure applied to a prosthetic limb. So the chip is in his brain, it relays a signal wirelessly to a prosthetic limb. In this image, Nathan Copeland is doing a handshake with President Barack Obama. And you can see Barack Obama's right hand is grasping a robotic hand in that image. Nathan Copeland can feel Barack Obama shaking that hand, and Nathan Copeland can also control that hand just by thinking, just by intending to shake hands in the way that those with the biological limb might just think about reaching out and shaking a hand. How is that possible? Because the advancements in artificial intelligence or intelligent machine architectures have made it possible for machine AI to actually communicate with the brain signaling in a human neural system. So this brain chip can actually transmit and receive signals from the brain of a person, send those signals, in this case, to prosthetic limb. That limb is engineered for sensation to detect pressure. So it will relay that signaling back to the brain chip, and the brain chip relays that signaling back to the human brain. In other words, here are human neurons and machine neurons talking to one another, communicating, in this case, in order to make it possible for someone who had traumatic brain injury or traumatic injury to their spinal cord to be able to regain some mobility, some sensation. And this is just one glimpse into the direction of the future work that is happening with machine intelligence combined with a human biological system. Just a few years ago in 2019, this individual did something that is also very important to understand as we try to recognize some of the important challenges and opportunities that are coming with technology advances, and particularly what that means for being human and for thinking about personhood. He Jiankui, pictured here as a Chinese biophysics researcher, he was an associate professor in the Department of Biology at the Southern University of Science and Technology in Shenzhen, China. And he had earned a PhD from Rice University in the United States, in Texas. His work had focused on protein evolution and included work on CRISPR. CRISPR is a technology for altering the genetic material in a cell by either removing some genetic material and replacing that material with new DNA. This makes it possible to edit genes, to change the genetic material of a person's biology. He used this technology in 2019 in order to alter the biology, the DNA of embryos of twin human embryos in order to make it possible for those twins to be born with an immunity to HIV. Okay, now this created tremendous interest and enthusiasm at first, but quickly garnered strong condemnation. It violated the ethical codes for genetic research in China, which does not allow people to change genetic material in a way that could produce genetic changes that would be inherited by the offspring of those who are being altered. In this case, he made these twin embryos that were born with immunity to HIV able to transmit that immunity to their children. So their descendants would inherit this immunity to HIV. So that was a violation of genetic engineering standards and protocols, not just in China, but globally. As a result of this work, he was incarcerated. He was sentenced to 3 years in prison in China, and he was fined the equivalent of about $500,000. Of course, he lost his job. But what is especially significant, I think, is just to understand, particularly in our age, where we're dealing with a global pandemic that has cost the world anywhere from 5 to 6 million people who have died from the COVID-19 virus, and upwards of that is seen by many experts as a severe undercount. Living in this era, is there not a legitimate interest in understanding the capacity of human engineering to ensure perhaps the very survival of the human species? In other words, although He Jianqui's work was widely condemned, we have to reckon with the fact that what he was doing is probably a mere glimpse into the further history, the further future of changing humans' genetic material, of literally rewriting our code to change our bodies. And when we think about this within the context of digital technologies, more broadly, we can begin to understand some of the possible changes to what it means to be human in the future. So here's one last example that shows some of the current and future directions of technology and the human. What you're looking at on this slide is an avatar system. So this is a microcircuit AI-enabled software device that has microchips that contain very tiny amounts of human cells. In this case, the cells of a human reproductive system. The cells include those from the ovaries and the liver and the fallopian tubes, vaginal cells. And with the exception of 1 or 2 types of cells, all of these was harvested from human patients. The ovarian cells are actually from a mouse. These cells were placed on this digital chip system so that the very small changes in the biological content or the biochemical changes, so that's called microfluidics, very small biochemical changes, can be sensed, measured, and processed by a software system. This miniature version of a human reproductive system is actually a functioning system. It actually has a menstrual cycle. So this system was developed by Northwestern University, and it was successful in allowing researchers to be able to test drugs on a human reproductive system. The aim was to have a human biological reproductive system that could receive experimental drugs. The impact of the drugs could be tested on this combination of software and human biology. The results could be processed, and researchers could find out by using these experimental drugs on the human biological system, how effective the drugs were without having to experiment on a person, okay? Because this chip system is not currently defined as a person. This is a miniature version, in other words, of a human, and specifically a human system. The ultimate goal by the ambitions of this kind of research is to be able to assemble not only a reproductive system, but an entire biological system on a digital software-enabled platform, so that by using very tiny amounts of all the cells in the human biological system, you could actually test the drug effects on an entire human. In other words, in the future, you might one day have a miniature digital biological version of you that's on a chip like this. If you need to receive drugs, or better have drugs designed specifically for your DNA, they could be tested on that miniature version of you first. And if that's successful, we could have confidence that the drugs would actually help you, the full person. This is another way that digital technology is actually interfacing with human systems in order to create what in this case is sort of a miniature cyborg, a mix of human and machine, and the application here being in order to promote medical research. So those are all examples of some of the changes that are happening in technology advancements. And they hint and gesture towards some of the ways that the near future, and that the present, and that the distant future will create amazing opportunities to advance capabilities for a human society and for an increasingly machine-oriented society, while also pointing to some of the important ethical and social challenges. I want to talk briefly about capital, about value, about the intersection of capital and race, particularly in order to clarify some of the equity questions and the justice questions that this future technology and future humans will have to contend with. What you're seeing here is a painting known as the slave ship that was produced in the 1800s, and it depicts something called the Zong murders. So you see in this image a ship that is about to be overturned in a sea storm. This occurred in 1781. The name of that ship was the Zong. It was used, as were hundreds of other ships, for human trafficking, particularly in the abduction and human trafficking of African peoples. In 1781, there were 130 people who were killed on the ship, and they were actually thrown overboard in an effort to save the ship from sinking in this storm. Because life insurance had been written on those 130 people, in fact, on all of the people who were being trafficked, who were being enslaved, the investors, the merchants, were able to be beneficiaries of cashing in that life insurance policy by claiming that they had lost their human cargo at sea and they should receive payment of the funds for the life insurance. Life insurance itself, in fact, was created in order to make human trafficking, specifically the African slave trade, more profitable, to ensure less risk for the European merchants who were investing their money in slavery, and to make it more profitable to pursue on a global scale the risk of capital in order to get these profits from human trafficking. That's the origin of life insurance. So the first people to be underwritten with life insurance policies were actually the people who were abducted from Africa, who were forced onto slave ships, and who were forced into these other lands, in the Americas, throughout the Caribbean, and even to Europe, for the profit and well-being and financial gain of those Europeans who created this global trafficking system. Today, life insurance works very different, but its origins actually lies a mechanism to make it more profitable to engage in human trafficking. This was true not only of life insurance, but of other things such as the promissory note. So at one time in this system of human trafficking, those who were enslaving Africans had to wait for someone to purchase them to bring bullion, that is metal, precious metals such as silver or copper or gold. And most frequently it was silver. It's very heavy, that had to be physically transported. This often took days or weeks to transport that material, that bullion. It was very difficult to transport, it's very costly. The promissory note replaced the physical transport of those precious metals. And it simply said that whoever held that note, whoever had possession of the note, was owed the metal. But instead of carrying around the metal, you could just carry around the note. If you happen to have any paper money on you today, you might take out your wallet and just look at it carefully. And it says that this note is legal tender for all debts. In other words, that money is a note, and it promises the person who holds it that they are owed the material that is supposed to be the actual bullion or money behind that note. Now, we know today the US dollar is not on a gold standard. There is no metal money. There's no precious metal that's backing it up. What's backing it up is a promise of a promise. So there's a double promise there. But the point is that the promissory note, what we think of today as paper money, was an invention that made it easier and more profitable to engage in the human trafficking of Black people globally. The same is true of credit. The credit system was an innovation in capital finance that was achieved singularly to enable, to optimize the profitability of human trafficking. All of those inventions, all of those innovations that I just named, the system of credit, life insurance, the promissory note, all of them expanded and became a regular part of how people in the so-called modern world deal with financial value. And lots of people benefit from those systems today. The fact that they had very perverse origins does not mean that they could not be put to better uses. But these are the origins of those systems. This is actually part of the racial history of capital. And it's why Achille Mbembe has devoted particular attention to the relationship between this history of slavery and capital and the future of technology. And he puts it this way. First, he notes, as I've indicated in the quote on this slide, that due to the Atlantic slave trade, men and women of African origin were transformed into human objects, human merchandise, human money. And if we think about that first slide I showed you, that there is this thing, this machine that's there that is being imbued with some of the privileges and rights that are typically associated exclusively with humans, we can understand one of the points that Mbembe makes, that the people who were targets and who were objectified and commoditized in this history of capital actually embody a very particular form of this question about the relationship between people and things. What happened when certain objects or things are treated with personhood in the case of that machine robot, Sophia, and what happens when biological human persons are actually governed and treated as objects that hold value as objects. And that's the part of the legal structure behind human trafficking. And he goes on to make several other points about this history of capital and its relationship to the future of value and wealth, and particularly what he calls the age of neoliberalism, which represents the age in the course of which he writes capitalism and animism, for so long having barely been kept distant from each other, finally cease to be apart. From the potential fusion, that is the combining of capitalism and animism, results a certain number of consequences that are very important for understanding the future of race and racism. And one of the concerns that Mbembe raises in this book from which this quote is taken, Critique of Black Reason, is that this slippage, this relationship between treating people as things and this future of technology of treating things with personhood, particularly intelligent machine things, of AI-enabled things, of objects that can have a conversation with you, that can parse your data, that can recommend to you what you should wear or let you know what the weather is going to be like today. That those things, that relationship is actually something that we have to consider together, that racial history of capital and that future. Because he says that what we are potentially seeing before us is what he calls the blackening of the world, is a future of capital in which all humans, not merely peoples of African descent, will be increasingly treated as merely sources of commodity value, exploited to the degree that they can be monetized. And to the degree that they cannot be monetized, treated as not having value in a world of growing inequality. One of the things that we can also understand historically is that the technology that has led to endowing greater capacities, greater capabilities for human constitution. And this is through designing new humans, changing our DNA, combining us with machines, using AI in order to design medicines or to extract our medical data in order to shape our world. That history is especially embodied in this individual, Henrietta Lacks, who, due to one of her biographers, has become much more familiar to people. So Henrietta Lacks was born in Roanoke, Virginia, actually not too far from where I am now, about 45 minutes from here. She was an African-American woman whose cells were removed during a biopsy that she had because she was actually stricken with cervical cancer. She didn't know that at the time. She was experiencing a lot of pain and illness, and she saw a doctor. And the one individual doctor, George Guy, took those cells. George Guy had been attempting to create a culture of cells that would continue to live long enough for very complex experiments to be done on those cells. And cells, human cells, typically will not live very long. They will divide about 6 or 7 times, and those cells just stop dividing. They just die out. If you're trying to perform biomedical research on those cells and you can't finish the experiment before those cells die, which probably from most research you're not going to be able to, it means you can't perform the research. Guy said, well, if we could have a line of cells that would not die, that would at least live a long time, if not forever, then we could conduct transformative research. What he found is that Henrietta Lacks' cells simply continued to live. They kept multiplying. Her cells were immortal. They did not die. Her cells today, this was 1951, her cells today have been used in virtually every area of biomedical research that requires cell cultures. And that's everything from the polio vaccine, which was developed in 1952, using her cells, to the research that's been done to develop vaccines for COVID-19. And this is in oncological research, as cancer research. It'd be difficult to identify any area of research that today is not using her cells. Henrietta Lacks herself did not benefit from this technology, even though her cells enabled tremendous unprecedented success and advancements in the technology that is improving people's lives, that is generating new treatments through all kinds of methods, of drug methods, of genetic research and genetic engineering. She died in poverty. Her family lived in poverty. Her descendants continued in poverty. And so one of the things that this history presses us to understand is that there is tremendous value, including monetary value and social value in terms of the benefits to people from Henrietta Lacks' cells, from the material from her body. But that value never translated into benefits for her family or her descendants. So how do we reckon with that? Here's one more example. And this is, again, looking at the technology that is going to continue to create new advances not just for human bodies, but for humans themselves in terms of what they're constituted as. So in 2013, the Myriad Genetics Corporation found itself in a legal ruling that went to the Supreme Court because Myriad Genetics had patented genes that were implicated in breast cancer. They did not invent these genes. What they did was to discover, they were able to find out which genes were actually implicated in this form of cancer. And when they discovered which genes were actually active in the formation of cancer, they created a test for women to be able to take to see if they had that genetic sequence, which meant that they were highly likely to develop this form of cancer. And they wouldn't allow anyone else, any other companies, to develop a test because they said it was copyright infringement. And they went on to patent other genes as well. Now, they didn't invent these genes. They simply figured out which genes, again, were implicated in this form of cancer. The US Supreme Court ruled in 2013 that the merely figuring out which genes were active and were part of this process of some disease did not give the company the right to patent those genes. This was significant because it meant that any corporation or lab could develop a test for cancer, for susceptibility to cancer based on this genetic sequence. And it meant that any other company or lab that figured out which genes were involved in any kind of biological process could not profit by having some exclusive control over the intellectual property and monetization of technology that came from understanding that. And it was called the fight to take back our genes. This had huge implications for the ability of researchers to do their work, but it also points to something else, because that same ruling said that if a company does actually change a gene, if they can design a new sequence of genes, they can own that DNA, they can own that sequence, and they can use that sequence for commercial purposes. They can benefit tremendously from the money that they're making, and they can also have exclusive intellectual control. They can patent it. Right, so this was a victory for the health researchers and the women who are not able to get access to more affordable screening tests, and for the work that was being done to treat this cancer. But it was also a victory for the future of possibilities of human engineering, of designing new code, the new data that is going to create the future bodies or shape the future bodies and the future selves of humans. It's another example of this relationship between technology, the human future, and financial value. No area of technology has been more transformative and lucrative than AI, than the software that is designed to figure out data, make decisions in the complex ways that artificial intelligence or machine intelligence can do today. And these are just a few of the companies that are in the AI space and the more broadly digital technology space. They are also the most valuable companies in the world. And here you see a relatively recent indication of the capitalization of these companies. This is just based on the stock price of the companies to try to understand what their market value is. And market value is just what the market is willing to pay for, in this case, shares of a company. So Apple is here at 2.8 trillion. Those of you who were watching last week know that they were briefly a $3 trillion company. The market is down a little bit, but they became the first $3 trillion company in the world. Apple was also the first $1 trillion company in 2018, the first $2 trillion company in 2020. Not far behind is Microsoft. Amazon is there at 1.7 trillion. Google, around the same. Tesla is now valued over $1 trillion. It's no mistake that all of these companies, all of them are incorporating digital technologies at the very center of their products, of what they're trying to monetize, of the services that they're providing the world. That digital technology future, in other words, and that digital technology present, which is very clear from understanding where these things are, is creating an unprecedented historical scale of wealth creation. Had you told someone in the 1990s that one day a company would be worth over $1 trillion, most people would have laughed at you and said, that's just absurd. There's no way one company could be worth that much. But today, here we are. There's several companies that are worth over $1 trillion. Now, I say that to say this, and I'll end with a couple of more examples of how we might understand the implications of where this is going. It's very clear from the work that has been done to use technology such as artificial intelligence to combine with people, to move us to a point where we no longer have to think of AI versus humans. We have to think of humans who are, at least in some part, very technologically modified, designed, changed. This is Claudia Mitchell in this image. She's doing a handshake or high five with another person who has been modified by being combined with an AI machine system. So Claudia Mitchell was in a severe accident that caused her to lose her left arm. Here she has what's called a smart prosthetic device that was designed, and this image is actually from the early 2000s, okay, that allows her to move that arm simply by thinking. So this is similar to what you saw with Nathan Copeland, who was shaking hands with Barack Obama. And she's shaking hand with another recipient. So she was the first woman to receive a smart prosthetic device. The man with whom she's shaking hands was the first man to receive a smart prosthetic device, both of them in the United States, both using the same technology. She has one prosthetic limb. There are two prosthetic limbs on Jesse, the man with whom she's doing the high five. And if we think about that within the context of where this technology has been and where it might go. So this is humans with machines, okay? This is a type of cyborg, a type of human machine combining. If we think of that in relationship to something else. So this is Shadu, and Shadu is a digital supermodel who has a large following, who has been a very valuable influencer. And if you are not a teenager, you might not know what an influencer is. If you're like I am and have to look it up, you know, it's someone who has a career, who makes money, who has a big societal impact by influencing what people buy, particularly. They influence consumer behavior. So Shadu is shown wearing the most interesting recent fashion, shoes or other clothing or some other accessory. But Shadu is purely software. This is not a biological person. Shadu is not the only digital influencer. There are other algorithms out there, AIs like Shadu, who exist purely as software, who are created by humans who produce code in order to generate the kind of renderings that they would like to. And these digital avatars, or you might call them digital workers, are actually creating value for the companies that design them. They have implications as well for humans who have been supermodels. Could human supermodels be replaced by these digital supermodels one day? It is a possibility. It would certainly be more profitable for the companies to actually use the software instead of paying humans. But there's also that question of what gets to count as human. Is Claudia Mitchell, is she less human because she's part machine, or does she remain fully human? If Shadu is fully machine, if this is all software, can there be any rightful claim on personhood? Or if we think back to Sophia, can there be any rightful claim on personhood? And I'll end with this. So this is an image of the cover of Xenogenesis by Octavia Butler, and we're going to have a really rich, fascinating panel shortly that will engage very broadly in a dynamic way with Butler's work. One of the things that Butler examines in her work is this line, this boundary around what it means to be human. And she does this in a very fascinating way. She talks about humans coexisting with, I will call them extraterrestrials. I'll put it that way. If you've not read Xenogenesis, which is a trilogy, please make time to engage with it in some way. The challenging question that she really asks is around the way the boundary of the human works. What she calls for, what she challenges is a very exclusive notion of who or what should get to count as human. And she makes a case, one might interpret it, as it's creative work. She makes a case for a more expansive understanding of what justice looks like beyond speciesism, beyond very narrow conceptions of personhood, in ways that are certainly disruptive and unsettling, but I think that are also important as we move into this further into this present and this near future and this distant future of the human and of technology, as we think about that within the context of the racial history of capital. And I would say there are important takeaways for us as we try to understand what these challenges might mean. One of the takeaways is that we have to get to shared prosperity because technology is producing, particularly digital technology and AI, is producing a level of new wealth and new value that most people could never have imagined just 15, 20 years ago. But that new value is not getting distributed in a shared way. It is getting distributed in a very concentrated way. And that means we have to think about new systems, new structures for the way capital does its work. And there are some important examples of state capitalism that allow not only private capital to prosper, but also public capital to prosper. And those examples are seen in nations such as Saudi Arabia and China. They're not happening in the West for the most part, although there are some important exceptions, but that will be one reckoning. Another takeaway, another implication of this is that we have to take seriously the function of the human as a political category, because that category has functioned to exclude millions of people from the benefits of human community. It has been used to dehumanize, at some point in time, most of the people in our world, on our planet. And we see that particularly in the ways that indigenous peoples have been dehumanized, that enslaved peoples have been dehumanized, that political enemies have been dehumanized because of, for instance, their commitments to social justice, that people have been dehumanized on the basis of gender identity. And as we move into this future, it will have to require us to have a very honest account of the category of the human as a political, not just a biological, not just a scientific category, but as a political category, which, looking at what Butler is gesturing toward, would imply that we cannot have this exclusive notion of what it means to be human. And finally, we have to understand that technology is not just a technical issue that can be solved by mathematicians alone or by those who are roboticists alone, that technology is as much a social, human problem and set of challenges as it is a technical challenge. In fact, I will add that the technical challenges, we've been able to solve many of them. The human societal challenges, if we were to make a list of the human challenges that we've solved with technology, I don't think we'd have a list. They're actually the most difficult problems to solve. And we need more humanists to participate in leading technology. So I want to thank you for this invitation to give a talk. These are some of my reflections on this set of challenges and opportunities before us. I think the future is, because it is not written, because it is open, is one that has to be approached with a lot of intention of deliberation, and a particular emphasis on the humanistic import of technology. I hope that as we move forward, particularly as a community, Stark King School for the Ministry, with our focus on justice, our commitment to equity, to advancing a world that is mitigating inequality, that is creating shared prosperity, that we are bringing those talents and that love for justice in a comprehensive way, however we're called to do so, however we envision that, in order to not be timid, but to be bold in participating in the leadership and the advancement of equity in a technological world. Thank you very much.